Hello friends, welcome to my channel. Let's have a look at problem 374. Guess number, higher or lower. So this problem actually is an easy problem, but it's very interesting. So this is an interesting game played by kids. So in this video, we're going to share a solution based on binary search or ternary search. And also we would like to explain why in general we consider binary search and ternary search but not other n-ary search. So what's the reason? So first I'll read through the problem statement and then we do the analysis. So we do the analysis by explaining the code when we write hand by hand. So here also we want to bring an extension to this problem, which actually shed light on why we have generally considered binary search or ternary search, but rather than other n-ary search. So first, let's look at the statement. We are playing the game, guess game. The game is as follows. So we pick a number from 1 to n. Notice that the number must in the range 1 and n, so both end inclusive. So we have to guess which number is picked. So every time, so we guessed wrong. So we are told that whether the number we picked is higher or lower than the guess. So this judgment is given through a predefined API. So this method is called guess. So if we get a 0 from the API, so it means that we are picking right. So if we are getting a -1, it means that our guess is higher than the number, right? So similarly for +1. So we are required to return the number picked. So here are examples. So the examples actually is just the sort of cannot mimic the process, but it's good to have. So here if n is 1, so you can only pick 1, right? So the constraint is that so n is greater than or equal to 1 and less than or equal to 2 to the power 31 minus 1. That is the 32-bit integer, right? Largest possible. So the pick is in between 1 and n, as we mentioned. So here actually we will going to write this solution using binary search and ternary search. So here, before we write code, let me first introduce this extension problem. So you can think of this. So given an integer m, so which is a positive integer, right? So we want to split it to smaller integers, so n0, n1 up to nk. So in other words, the sum of these numbers equals to the m. And then we want the product is maximized. So how do we do the split? So actually you can consider this problem also. So given an integer n, so we want to split it into several parts. We want those parts to be as close as possible and such that the product is maximized. And then so you can think about the relation of 2 and 3 and with respect to e. So where e is a natural base, which is roughly 2.7, right? So if you compute this, actually if you use basic calculus, so basically you will compute some derivatives and then you will get some critical point, which is e or something alike. So you will see, oh, so because this the search domain is integers, so the nearest integer to e is either 2 or 3. That's why we have a 2 and 3, and we compare the nearest possible values near the critical points. So that's actually some hint for this problem. So you can try, or you can think of the Lagrange multipliers in general. So that's actually the problem or the main purpose for this video. So the next part actually is very routine. So I'm going to practice the use of binary search. But for this problem, this is very special because this target number must be in between 1 and n. So we can always get the desired number, right? So for this, first I'm going to write one with binary search. So this corresponds to 2 is smaller than E, right? So for this, I'm going to introduce low and high, so which is 1 and n, right? And then I'm going to do this, low less than or equal to, in this case I wrote. The reason is that we must be able to find the target or the numbers and the other part picked. So here I'm going to introduce middle as before. So I'm going to call this low plus high over 2. Yeah, sometimes you can do this, right? Depends on the direction you want to do the shrinkage. You can do mid equals a low plus a half of the distance, right? High minus low over 2. Or you can do mid equals high minus the high, this delta, right? So this part. So these are details actually in the complex use cases. So we need to determine which direction we should to use to do the shrinkage of interval. So in overall, actually for doing binary search, so there are 2 big considerations. First is the search scope, or the search space. Secondly is how we do the search space shrinkage, right, in a half by half way. So but still we can make it very general. So for some problem, we need to define our own Boolean function to produce monotonicity or order relation. So for this, actually you can see the binary search playlist in my channel for more information and for more use cases. So without further ado, let's continue first finishing this problem. So then I'm going to call this API. So this G, I'm going to call it guess of middle, right? So according to the problem requirement, if G equals 0, I'm going to return the mid, right? So otherwise, so if G is less than 0, so it means that so let's check directly using let's say -1 or +1. Let's say use 1. So if J equals 1, it means our guess is lower than the number, right? So we want to do this. Low is mid +1. The reason is that the condition J equals 1 tells us mid is not the number. So we start from low equals mid +1. In other words, we do not start from mid. So in other case, so J equals -1 mean that our guess is higher. So we're going to do high equals mid -1. So mid -1 means that the condition J equals -1 tells us mid is not a valid guess. So we have this. So for now, actually we can end the program or the coding. The reason for this problem is that the target in mind must lie in between 1 and n, both ends inclusive. So we must be able to return something. So I'll stop here and do the test. Yeah, it passes this example 1. Now let's do a generic case check. Yeah, it passes all the generic cases. So this actually is the method typically we think of. So I'm going to mark this as version v1, and then let's copy this function signature part. So I'm going to write a solution based on ternary search. So in other words, three-based shrinkage of searching scope. So this is actually nothing special, but still I want to bring you the attention of this problem, and then if you can solve this problem and with some deep understanding, you will know the difference of binary search and ternary search, and their pros and cons, and their comparison of the actual number of unit time used for getting this target number. So for this, still I'm going to introduce low and high equals 1 and m, right? So then let's do this again. Low less than or equal to high. So again, we include an equal sign here. So for this, first I'm going to let's look at the comment here. I'm going to introduce this delta, right? This delta equals high minus low over 3. So here over is integer division, right? So now in the first method, so we actually split the search scope between low and high by half and half. So now we do ternary split and do the shrinkage. So here first let me so mid 1, mid 2. So mid 1 actually equals low plus this delta, right? So we can see that, so this moves 1 delta. So and then the mid 2 is actually, you can use low plus 2 delta or high minus 1 delta. So that's the two. You can understand this as two middle points or two thresholds. So notice that mid 2 is no less than mid 1, right? So then let's call this guess API. So guess mid 1 and guess mid 2, right? So then actually we can first check if G1 equals 0. So right. So if this is the case, actually we just need to return the mid 1. Otherwise, if G2 equals 0, so we just return mid 2. So other case, so both G1 and G2 are non-zero. So if G1 is less than 0, so that in other words it's negative 1. So the number we guessed should be is too large. So we can actually do this. High equals mid 1 minus 1, right? Otherwise, so if G2 is larger than 0, in other words, our guess for mid 2 is still small. So in this case, so we're going to do low equals mid 2 plus 1. So all the other cases, so which actually makes sure the target is in between mid 1 and mid 2, but the two ends not included. So in this case, we're going to do mid 1 plus 1 and high equals mid 2 minus 1. So again, up to here, I do not want to write any return. The reason is that due to the problem assumption, so we must have already found the number. So let's do a check here. Yeah, so not generic case. Yeah, it passes all the generic cases. So with that said, actually, so that's about it for this easy problem. But this problem is easy, but it's very interesting. So I will encourage you to look at this extension problem and come up with some idea. And also you can try to identify some problems so which can use this extension. For example, how we split a string, right, with some condition. I remember one problem which also I wrote a analysis. So it involves the natural log e and split the list into piece of length 3. So with that said, I guess that's about it for this problem. So you are welcome to check out the binary search playlist video in my channel, in which I explained how to define Boolean function to produce monotonicity, how to do search space shrinkage. So with that said, I guess that's about it for this video. Thank you.